Alright, so I figured out why my circuit looks so weird. Things that come to you when you get a little sleep. So sitting here this morning, it's like, oh, I get it. So let me show you. So with the decoder, let's say that the function that we are trying to implement is the sum of minterms. Let's say 0, 1, 10, 11. And we're using a decoder for that. I just made those up, by the way. Someone asked me, are you supposed to make them up? No, you're not supposed to make them up. You're supposed to use the ones on the lab. I just didn't want to do your particular lab. Okay, so what you would do is we'll take our decoder and if you have, so if, let me just grab this and let me show you. So let's say your inputs A0, A1, A2 are let me just do this with just 3 bits, and then I'll come back in a minute and show you what to do if we need to extend it. So let's say I had 1, 1, whoops, I had 0, 1, 1. Notice this is backwards. Here's our most significant bit. We would normally write this with our most significant bit in front, so 1, 1, 0. So A2, so A0 corresponds to the 1's digit, A1 to the 2's digit, and A2 to the 4's digit. So 6, which we normally write as 1, 1, 0. So this would mean A0 is 0, A1 is 1, and A2 is 1. So if those are our inputs to our multiplexer, then if we look here at our truth table, then so that would be so we have A0, so we have low, high, high, so low, high, high, and that's this row right here. And you see what that corresponds to is that output 6 is low, and the other outputs are all high. So if the sum of our minterms, if we're looking for the function that has 0, 1, and 6, then we're looking for either output 0 to be low, output 1 to be low, or output 6 to be low. If any of those are low, then we are good to go. So we want to take from our multiplexer our outputs 0, 1, 2, 3, 4, 5, 6, 7. So if we had 0 outputs, I would want in my particular function that was 0, 1, and 6, I need to take, I didn't have to put 0 on here, I need to take 0, 1, and 6, and I would want the OR of those if those were high, but they're not, they're low, so I want to take the OR of their nots, and the OR of their nots is the same as the NAND. So I can either put an inverter in there, or it's easier to make a NAND gate out of it. So depending on how many you need to NAND together, you could do that. So you can, instead of using the inverters in the OR, you could also use a 3-input NAND gate if you have 3 of them. Just be aware that you can't say that if you needed to have more than 3, if I do a NAND and a NAND and then I NAND these together, that's not going to get the output that I want. So that's not that does not work. You can't, the NAND doesn't work that way. Now, how do I get, if my decoder only has 0 through 7, how do I get 8 through 15? So I actually, my inputs, I actually have 4 inputs. I have, what were they, RS, RS, T, and U. So R, S, T, and U. And so I believe that would be A0, A1, A2 based on your instructions. Yes. Okay. So how do you get, you can use the first multiplexer, and this would be A3. You can use the first decoder to get that. Now, how would you use the second decoder? So, okay, so our second decoder also has an A0, A1, and A2 on it. And these outputs, so they would be labeled 0, 1, 2, 3, 4, 5, 6, 7. But we want them to correspond to 8, 9, 10, 11, 12, 13, 14, 8, 9, 10, 11, 12, 13, 14. $15. So what am I missing? 1, 2, I can't count. 3, 4, 5, 6, 7. Okay, so if we think about our binary numbers, all of these numbers, 8 through 15, are going to have A3 equal to 1. So starting with 8, 8 is 1, 0, 0, 0. And then 9 is 1, 0, 0, 1. So they all have, the first bit is 1 for all of them. And so if I take if I let this first bit be the enable for this, and then use these for A0, A1, and A2, then this will give me the correct result when this first bit is 1. So if you look at your truth table, the first bit, if I let that first bit go into E3, then when it's low, then if this is low, then all of my outputs will be high, and so none of them will be low, so none of them will be indicated. So you want R to go to E3 because you only want it to be enabled when this first bit is 1. So then if I had a number like 0, 1, 0, 1, then the 0 going into E3, that means that this decoder would not be enabled because E3 needs to be high for it to be enabled. It'd be low, so you wouldn't get anything. And this one would give an output on the first one. But to get, if I wanted 1, 0, 0, 1 to give me my output, then if this goes into E3, then that will give me the correct answer. Now, on the same principle, I need to make sure that I don't, so this number is 9. I want to make sure I don't also get 1 from the first decoder, and so for the first decoder, I need the not of R to go into E3 because I need it to be disabled when this first one is 1. So if I have my two decoders, E3, E3. And I have my number A3, A2, A1, A0. I need the not of this to go into that one, and it just to go into this one, and then A0, A1, A2. And these correspond to RS. What were they? RS, T, and U. Okay.